Hi, everybody, and welcome to Adler Astronomy Live. My name is Meredith. I'm going to be your host today, and we're going to be talking about space ethics. So we're so happy that you're joining us. As many of you know, the Adler Planetarium is currently closed to the public, as museums are all across the United States and the world, actually. Because of this, we're trying to bring some of our awesome programming online to you. And one of the things we pride ourselves on here at the Adler is that folks are able to walk into our building and talk to real live experts and astronomers about their field of science. So we're trying to bring that to you today. We have some awesome experts with us. As you can see, we are just currently in our homes. Because of that, who knows what'll happen? We might have a technical difficulty, or perhaps you might get a special appearance by somebody's pet or child. My husband just voted and he wants to show off his voting sticker, and I might let him because, voting is awesome. So yeah, because of these circumstances, we just ask for your patience and understanding, and we hope that you are ready to have some fun with us. Okay, let's introduce our experts. First of all, we have Lucianne Walkowicz. Hi, Lucianne. Yay.
Hey. How's it going?
Great, how are you?
So good. So excited for today's talk.
I know, me too. Do you have any fun Halloween plans coming up? What are you going to be for Halloween?
Lazy on the couch.
Yes, I love that. I've been in that costume for 7 months now.
Oh, yeah, me too. What a coincidence.
I love that. Also with us, we have Aaron Geller. Hi, Aaron.
Hi, Meredith.
What are you going to be for Halloween?
Well, my kids want me to be Sven, the reindeer from Frozen. I don't actually have that costume, so I'm not quite sure how it's going to work out, but we'll see.
Just improvise, use your acting skills, just become Sven.
Yes.
Cotton balls.
Yes. Okay, awesome. Well, let me tell you about Lucianne and Aaron for a second here. Lucianne is an astronomer at the Adler. They are interested in all sorts of different things, like how stars affect the chances for planets to host alien life and the ethics of space exploration. Those things go hand in hand. And Aaron is also an astronomer here at the Adler and at Northwestern, and he studies how stars and planets are born and how they change over time. Also behind the scenes with us today, we have Mark Subarao, our visualization expert, who's going to be running all the visual elements you see today. And I talked to him earlier, and for Halloween, he said he's going to be Mr. Mistopheles from Cats, the movie version. So today's program is meant to be totally interactive, which means we want to hear from you. So please utilize the chat function in YouTube. We have my good friend Sarah in there who's going to be joining you. Everybody say hi to Sarah and send her your questions. She'll get the questions over to us. No question is ever dumb or bad. We love hearing from you. And especially when we're having such an awesome conversation today about space ethics. Bride, did you want to show off your, my husband is literally wants to show off his, hey, voting is cool. He voted. Yeah. Vote, everybody. It's getting down to crunch time. So as I was saying, today's a fun, silly episode. Yes, Lucianne, talk so that you show up.
I will also tell you that this was made by an astronomer, Emily Gilbert, who was on our exoplanets episode of Adler Astronomy Live. If you want to go back and watch that, knitted this and sent it to me. Look at
Emily.
that. She made that. And
that is amazing.
Discovered an Earth-sized habitable zone planet. No big.
I already thought that Emily was like the coolest person I've ever met, but the fact that she made that is unreal. That might be the best vote merchandise I've ever seen. It's beautiful.
Yeah, she actually also made me a candy corn hat, but it's out of reach. So maybe that's what I'll be for Halloween.
I have a mushroom hat. I'm gonna be a mushroom for Halloween. Okay, amazing. Let's get back to space ethics. Okay, so usually when we talk about exploring space, we think about things like the technical challenges of going to space. We think about how can we launch rockets? How can we design rovers and other robotic probes? And in the case of sending humans to space, how can we keep people safe when we send them to space? Many of the challenges of going to space, especially when we start talking about putting humans in space or on other planets, whether that's to visit or to live, are the ethical and social questions, not really the technical ones. So we're super lucky to have Lucianne with us today because they are a triple threat. They're an expert in astronomy, social science, and in making dioramas, which is unrelated to this, but I might plug our other program where Lucianne made an amazing diorama later. But for real, they place just as much importance on social and ethical questions as they do on astronomy, physics, and technical stuff. So we're super lucky to have you with us, Lucianne, because you're such an expert in this. So yeah, let's start talking about it. And why don't we start with Mars, since a lot of times when we think about space exploration and humans, you know, visiting or even living on other planets, we think about Mars. And people have been thinking about this for a long time. And we actually have some really cool collections pieces to go along with this topic. So Mark, if you don't mind pulling those up, and then Lucianne, can you tell us about these?
Yeah, I'll just start while Mark is pulling up these beautiful images. So these images are paintings, and they're in the Adler's collection. And this first one here is showing you an imagined exoplanet. So you're standing on the surface of this and looking out at these stars, and these particular stars are near the ends of their lives. So this is imagining a very different planetary system than even we have. But Chesley Bonestell, the person who made these paintings, is really known as the father of modern space art. Really, really visionary, incredible pieces. The one that you're seeing here, it might seem sort of ordinary. Oh, it's the space shuttle, you know, flying over an area of a planet, you know, maybe it's Earth. This was way before the space shuttle existed. So Chesley Bonestell is super significant because he was working throughout the 20th century and making these paintings that are really credited with giving us a very like tangible vision of what it would look like for human beings to explore space. And many of these, you know, predate humans going to space. They predate certainly humans landing on space. Or space objects, you know, being out on the surface of another world. And we take for granted now that we have things like landscape photography of Mars that we're going to look at later. But Chesley Bonestell was really some of the person who gave us these first imagined images. And in particular, one of the things that he did was he worked with scientists who were working on the rocketry program and on the what would become the human space program, and created like a series of these paintings for Collier's magazine. And Collier's isn't really around now, but it was kind of like a Time or a Newsweek. It was like a super common, popular magazine with like news and, you know, human interest stories, all that stuff. So by working with them, with the scientists to create these images, he is credited with helping cement these images of human beings walking around on the surface of other worlds. And it really played this very, very significant role in providing the popular motivation and the public support for humans going to space. And of course, some of them are so beautiful. They this picture of Mars, which you're seeing painted from afar from the surface of one of its moons, you know, super predates our ability to take pictures like this. So it's really quite visionary and quite incredible.
Yeah, it really is inspirational. I can see how somebody might see an image like this and feel like they're really there, and that might just help inspire them to like make it happen. So the other thing about Mars and why we've always thought about traveling there is Mars is super visible in the sky. So human beings have been, you know, looking at Mars for a really long time. Aaron, can you tell us about how we can see Mars now?
Yeah, sure. I'll be happy to. Mark is just throwing up right now a view of the night sky from Chicago tonight. And you can see Mars there right in the middle. Mars is going to be visible all night, more or less. It's rising in the east. You can find it in the constellation Pisces. And it's easy to see even with low power telescopes or with your bare eyes. It's, you know, at times like these, it can be the brightest object in the sky, although tonight the moon will be up, so that'll be more bright. And speaking of the moon, if you look toward the south, you'll have an interesting shot of the moon right near Saturn and Jupiter. So I really encourage you to go out and look for Mars tonight. Let me also say, if you can't do that, or if it's cloudy out tonight like it is by me right now, you can also take a look at Mars on our show Sky Observers Hangout, the Adler show Sky Observers Hangout, which is on YouTube. And there's actually 2 episodes on Mars that you can go take a look at after the show is over. This is also really a special time to look at Mars. because on October 13th, Mars was in opposition. And Mark just switched to a view from space, looking basically down on our solar system, where you have the sun kind of on the left, you have the Earth in that blue kind of arc, that's the Earth's orbit, and then Mars's orbit on the right, all the way on the right. So the Earth is right in the middle, and Mars and Earth are lined up like this, opposite this. Mars is opposite from the sun. And that's what we mean by opposition. And as you can see here, this is where Mars and Earth come closest together. So that's why it's such a great time of year to go out and try to look at Mars. This happens just about every 26 months. And while we have this up here, in case you're wondering, that green line there is the path of NASA's Perseverance mission, which is on its way to Mars. And we will come back to that shortly.
So cool, sneak peek. So like I was saying, and like Aaron was saying, you can see Mars, you know, just with your naked eye here on Earth. But as telescopes got better, we could see it in better detail. We got to see, you know, that red color and some of the surface. But it wasn't until we started to send our first missions to Mars that we really got to know our neighboring planet. Ooh, cool. Mark, you're zooming us in. I love this. So Lucianne, can you talk about those missions a little bit?
Yeah, you know, for a very long time, Mars has really occupied this very special place in the human imagination about people going to space. You know, there are many places that we do go and can go, but we've chosen to focus on Mars today in part because of this very like significant place of imaginary that it occupies. So, you know, even back to early observations of Mars, and you can observe this yourself. It's actually, if you're in Chicago, it's supposed to clear up tonight. So super fingers crossed that you'll be able to see Mars. But even with, you know, like a low powered telescope or binoculars, you can often make out that there are dark and bright patches on the surface of Mars. And as telescopes developed, people noticed these, made maps of them. And significantly, an astronomer, Schiaparelli, was the first person to notice that there were these sort of long, dark lines, which he referred to as canali because he was Italian, and got mistranslated as canals. And this idea that Mars had canals, you know, which contrary to being like rivers on Earth, canals aren't natural features, right? They're built by human beings, at least here on Earth. So this idea that Mars maybe was occupied by some kind of intelligent life that made these like large scale, you know, canal engineering projects that we associate with human life here on Earth really took hold in the popular imagination. But it wasn't really until the 1970s that we started to send missions to Mars and actually be able to look at what the surface is like and see it in detail. And at the time, you know, really up until the Vikings missions went in the 70s, scientists really thought that they were going to land on Mars and discover life like pretty much right away. And instead, what happened was they got to the surface of Mars and it, you know, was very dry. It was, you know, this seemingly barren desert. And actually for a while, it was like very disappointing. You know, yeah, I mean, like imagine thinking that you're going to be like, yeah, we found life. And then like you get there and it's a barren looking desert. But I will say that I love the deserts of Earth and they are teeming with life, even though they don't look at it. So it look like it. So, you know, now we actually have much, much more detailed knowledge about the surface of Mars. And we've been able to study the history of Mars by looking at those rocks and the chemistry and physics that is there on the surface. So now we have a whole bunch of new missions. And Aaron, I think you were going to update us about all of the new missions that are headed to Mars right now as we speak.
Yeah, thank you. I'd be happy to do that. And I just want to like reiterate how, because we were talking about this beforehand, how like if you can imagine going back to the time before we had this type of knowledge of Mars that we do now, and think about the excitement of like there might have been actual real alien like people walking around on Mars and people actually thinking that. And we've come a long way from that vision of Mars, but it's still very exciting. There's still a lot that we don't know. And for that reason, there's actually 3 separate missions right now headed to Mars. One of them is this green line that we talked about, NASA's Perseverance mission that actually has Perseverance rover and an Ingenuity helicopter. So imagine there may be a helicopter that can fly on Mars. This will be the first time that anything's flying like that on another planet. It's just a test, a flight test. And I should note that we'll have some special Adler programming in February 2021 when Perseverance mission is going to reach Mars. So stay tuned for that. But in addition to the NASA mission, there's also the HOPE orbiter, which is the first mission from the United Arab Emirates. So that's very exciting. And that's going to take images of Mars to study the atmosphere and the weather on Mars. And then there's also the Tianwen-1 mission from China, which is just packed full of instruments. It's going to have an orbiter, it's going to have a lander and a rover. So that's going to bring back some really interesting information as well.
So cool. So many missions. Okay, we have some awesome questions coming in. First, Amanda Green wants to know, how different would it be to send someone to Mars versus the moon?
Oh, that's a great question. So, I think one of the things that is easy to forget is that the moon is basically in our backyard. I mean, it takes a lot to get to the moon, and it certainly was like a gargantuan effort, both in human power and in like financial terms to send astronauts to the surface of the moon. But the moon can be reached in like a few days, whereas Mars is a minimum of a 6-month trip. And more than that, going to Mars, it's not just like a matter of distance and time. It's also that we leave the Earth-Moon system. So, here on Earth, for example, the astronauts that live in the International Space Station, the ISS, are protected from a lot of the most significant effects of like radiation in space, solar flares, things like that, by the Earth's own magnetic field, because, they're in space, but they're still pretty close to home. And when you start to send people on these very long duration missions, the potential for people to incur like significant bodily harm, even like if the mission is going perfectly, is a lot. And so it's not just a matter of like resources and distance and time. It's also that we really don't know what would happen to the human body over these like long distances and durations. And, like we're only touching on kind of a small slice of space ethics today. But the medical ethics of sending people on long duration space flights to go to Mars versus the moon, for example, is a whole field in and of itself, because it's essentially like a big open-ended experiment that you can't test beforehand. And, in medical experiments on Earth, consent plays a really big role. And so, how do you give people informed consent when like you don't actually know all of the things that you might need to warn them about? And what happens if like 5 months into the 6-month trip to Mars, you decide you withdraw your consent? It's not a medical experiment on Earth that you can't just turn around and go home. So yeah, it's a lot harder, I think, is the short answer.
Yes. So farther and a lot more things to account for. So we have a question from Becky here, who just wants to know about the materials that are left in space. Are there plans for retrieving those materials, recycling? As we think about all these things that we send up that are orbiting the Earth, and their usefulness passes, what are the plans for those items?
Yeah, also a great question. So when we are thinking about sending things into space, I think something that gets glossed over is that like humans just leave their trash everywhere. Like we leave it in Earth orbit, we leave it on the surface of the moon, we leave it on Mars. All of the stuff that we have sent up to space is more or less still up there. So a few things get deorbited, but very few things. So, when we talk about the near Earth environment and sending like satellites up, especially with some of these plans to send up like tens of thousands of satellites, then we have companies that are looking at how to retrieve what we call space debris. But, when we are thinking about going to like the moon or Mars, retrieval is not so easy. And so actually earlier this week, we had a meeting of the NASA Astrophysics Advisory Committee and heard about Artemis, this new like plan to go to the moon. And one of the big significant things was that like a lot of machinery doesn't survive the lunar night, meaning that like things last a month and then it gets too cold because they end up in shadow and your electronics break. And so everybody on the committee, we're like charged with making sure NASA's doing a good job and providing oversight. And we were kind of like, wait, you're just going to send a bunch of stuff up there and then it's not going to be good 30 days later? What are we going to do about leaving a bunch of like dead machines all over the surface of the moon? And, you know, I was very pleased to see that the Artemis team is thinking about those things and also thinking about planetary protection for the moon, which we'll talk about a little bit later.
Awesome. That's awesome. Okay, we do have a question here from Brian Garrison, who wants to know how you would compare the Perseverance mission to the, or is it Orisis REX mission? Did I say that right? Osiris. Cool. How would you compare those two missions?
Do you want to take this, Aaron?
Yeah, I can start. Well, I guess for the viewers that don't know, OSIRIS-REx is a mission that just actually touched down on an asteroid and grabbed a little sample. So that's really exciting. And so there's a difference there that, you know, that it's at two different locations, right? One was going to an asteroid, one's going to Mars. Perseverance is going to have a lander, and it's going to kind of rove around on the surface of Mars a bit more. So there's a little difference there as well. Of course, they both have to go up on rockets, and they both travel in space. I don't know, Lucienne, did you want to add anything to that?
Yeah, I think so. Both Perseverance and OSIRIS-REx are taking like samples, soil samples or dirt samples or whatever you want to say it. So I liked, my favorite description of OSIRIS-REx was that it booped an asteroid. So it just kind of went and grabbed a little mouthful of asteroid dirt, as my fellow astronomer Jonathan McDowell put it, which I really liked. And I think OSIRIS-REx does return back to the Earth with that sample. So, which I'm not 100% sure about. I haven't been keeping up on OSIRIS-REx the way I should be. Perseverance, on the other hand, is also going to take samples, but returning something from the surface of Mars is a lot more difficult. And so what they're hoping to do is to cache those samples, to take them and put them in little containers, and then make it easy for future missions, potentially even human missions, to go and pick those samples up and bring them home to Earth, where they can be analyzed in labs. So instead of doing one big Mars sample return mission, where it will, go and grab a sample and then come back, which is like hugely difficult, very expensive. They decided to break it into two parts, where Perseverance can go there, cache up some samples, do a bunch of science, and then later on, we can send another mission that will do more science, and then we'll actually be able to maybe return those things to Earth.
So cool. And Mark, sitting behind the scenes, you can't see him. He's dressed in his Mr. Mistopheles costume. He did confirm that, yes, it is going to be returning to Earth on September 24th, 2023. So, you know your stuff, Lucienne. Okay, so I do want to talk about all these different missions and how they're all coordinated. Like, how do these different folks coordinate their missions going to Mars? But first, let's do a nice smooth transition into a donation pitch. As you all know, the Adler is closed. Because of that, we're trying to bring these programs to you, and your donations help to make these programs happen and to keep the Adler alive. So if anybody is willing and able to donate today, Sarah is going to go ahead and share a link for donating, and you can donate any amount. Any amount is welcome. No amount is ever too small. You could potentially donate $4 for the number of rovers NASA has landed on Mars, or potentially $560 for roughly the number of people who have traveled into space. Or maybe it's $1971 for the year that the first human-made object landed on Mars, which was for the Russian Mars 3. So any amount is welcome, and we are so appreciative to everybody who has donated so far. Keeping museums going is something that it's so important right now while we are all in this pandemic. Okay, let's talk about all these different space missions doing different things. Some just go near to other worlds. Others might land on or travel over the surface of other worlds. When we create these missions to go to other planets, especially places that might potentially have life, we have to be careful not to contaminate these places with life from Earth or vice versa. That's a part of what we call planetary protection. And Lucienne is an expert on planetary protection. Can you tell us exactly what this is, Lucienne?
Sure. Yeah. So right now what you're seeing is the Curiosity rover. So this is one of those examples of something where we actually landed a object that travels over the surface of Mars and is very much in touch with the surface, right? Like it's trying to dig around and scratch and drill and study all of those things that tell us that, while in the 70s we didn't land on the surface of Mars and, immediately see like people walking around or anything, what we have learned over the years is that we probably are seeing in the chemical signatures of what is there, the history of a world that was once upon a time potentially much more habitable, more hospitable to life. Now, whether life existed there or not, we don't know, but there could be a history of it, or it could even exist in microbial form or under the surface today. So planetary protection is super important for Mars because it comes from this super significant document, the thing that really sets all of our norms of behavior in space, called the Outer Space Treaty of 1967. And what the Outer Space Treaty does is it establishes, what you can and can't and should do in space. And it's really, it's pretty readable if you just want to like look it up. It sets forth all these very utopian sounding things like that space is for the good of all humankind, et cetera. And it very significantly has this Article 9, which sets forth what we now call planetary protection. And that's the idea that when we go to other worlds, we want to be sure that we don't bring anything back that might contaminate the biosphere of Earth and pose a risk to our ecology here. And we also don't want to take anything to other worlds that would then contaminate those worlds and either create damage to the ecology of another planet or even potentially mess us up when we go to look for life, right? So that means that when NASA and other space agencies send missions like the one we're seeing here, this is the Curiosity rover landing on Mars, an animation of it. We are very, very, very careful to clean those spacecraft. And I'm talking like down to the 5th microbe. You have to be super, super careful about how well we clean the things that we send to other planets.
Yes, this is so important. And actually, Stephen Cosgrove asked a great question about terraforming being ethical or unethical. Where does terraforming fit into this?
Yeah, that's a great, great question. So one of the things about planetary protection is that it's pretty nuanced. So there are worlds like the moon that we don't think of as harboring life that have essentially no regulation about what you can do on them. Mars is significant enough that it has actually 5 like subcategories of protection based on where you might want to go and what you might want to do. So with the most stringent protection being for missions that are trying to actually detect life or going to places on the planet or inside the planet even that life might be. So when we think about something like terraforming, so first of all, just like basic definition, if you've never heard that word, terraforming is the idea that you could engineer a planet's environment to be more like the Earth. So in other words, a lot of visions that we have of going to Mars involve astronauts being in spacesuits and walking around the surface because Mars is not hospitable to human life as we know it today, or really ever. So, when we think about going to Mars, some people have put out this idea either in science fiction or in private space that I think we're going to talk about in a moment, that you might be able to alter the Martian environment to make it so that humans could maybe live on the surface without spacesuits and fancy habitats. So there's all kinds of ethical questions like tied up in terraforming. From a scientific perspective, most ideas about terraforming just straight up like don't work based on the materials that are available on Mars. But they also fold in ideas about like environmental protection that we grapple with here on Earth. So one idea about terraforming would be that you would have to strip mine the entire surface of the planet in order to release enough carbon dioxide to make the planet like a little bit warmer and maybe have liquid water on the surface. It technically speaking, it doesn't work anyway, but also like strip mining is something that we do here on our own planet that actually makes places less habitable for human beings, right? Strip mines are places of environmental contamination. And also, even if we could like somehow terraform the planet in such a way that would not be like harmful to us, we would also be kind of erasing the chemical history of, potentially of life that might have existed on the planet itself. And we'd be altering the chemistry of the planet such that certain questions, like whether life existed on Mars, whether it was independent of life on Earth, those might not be answerable again. So, it really comes down to, and a lot of ethics questions are like this, it comes down to your value system and whether you think other worlds are, sovereign places in and of themselves, or whether you think you have the right to use environments in whatever way you see fit. And also whether environments are like tied, whether their value is even just like tied to life or not. So it's a really sticky question. I personally, my answer is no, it is not. And also, like, I personally am motivated by finding, signs of life, past or present, on Mars. And so, like, I wouldn't want to give up the ability to answer that question just so that I could maybe walk around without a spacesuit.
I love that answer, and I'm with you, Lucianne. Okay, so when you're talking about these different categories and protection categories, King Darius 2100 has a great question about, and joining us from downtown Chicago. Would Venus and Mars be in the same protection category? I mean, we're talking so much about Venus potentially harboring life right now. So are those kind of in that same category?
Yeah, that's a great question. So Mars and Venus are really, really different. They're both considered potentially habitable worlds, but Mars, by contrast, is very, very thin atmosphere, super dry, very cold. It doesn't have like a lot of atmosphere to hold in heat. Whereas Venus is, got this very like thick atmosphere. It's like 800 degrees Fahrenheit on the surface, super hot. And Venus is a place that, up until like a couple of months ago, has been sort of unpopular from the standpoint of looking for life. But, most of the planetary protection categories that are actually spelled out are for Mars, because of Mars's like special place and all of the attention that it's historically gotten. One of the things that is happening right now with planetary protection is that while, this like category of planetary protection is specifically about Mars, there's a realization, right, that we made up these categories a really long time ago, and our knowledge of these worlds, including Venus, has changed a lot. And so I wouldn't be surprised if there were future planetary protection changes. And this is something that's like actively happening within the scientific community now, is reevaluating planetary protection that made Venus more of a part of that explicitly, even though currently it's really not. And that, looked at things like the moon, because, the moon is not just like a dead rock. Like, we don't think it has life on it, but it has like cultural significance. It has places that there is actually water, which we didn't know about several decades ago. I think we didn't even know about it like 2 decades ago. So, there's a lot of nuance to where you might want to go and where you might want to explore and what you might want to do, that really challenges what we have in the way of planetary protection.
Yeah, wow, that is a lot to think about. And if anybody out there is like, what are we talking about Venus for? You can actually check out a couple of weeks ago, or maybe it's a month ago now, we had an Adler Astronomy Live, a special one, talking to some experts who helped discover phosphine around Venus, which is a potential sign of life. So go back and check that out after this. Okay, so let's talk about, we've been talking a lot about, Lucianne, you're doing a lot of work with NASA talking about planetary protection, but there are a lot of private companies beginning to send spacecraft into space and talking about potentially sending things to other planets. Is there anything that we should be concerned about here when it comes to private companies?
Yeah, I mean, I definitely think so. When we look at the marketing, for example, of private companies, and I think in a moment, Mark is going to pull up this particular video from SpaceX that's from a couple of years ago. So SpaceX is not particularly special in any, scope of like private space companies. There's a lot of them. There's like Bigelow Aerospace, there's Blue Origin, which is Jeff Bezos's company. Lots of things, even smaller companies like Rocket Labs that want to go to Venus specifically. So all of these companies, right, are what we call new space. They're private space companies that are different in the sense that, they're not the old defense contractors that have built a lot of space missions like Lockheed Martin or Northrop Grumman, for example. And one of the things that I think sets them apart is that SpaceX in particular produces these like very fancy marketing videos that have this like big wow factor, like the one we're watching right now. And what these images really do for us, in the same way that the Chesley Bonestell paintings sculpted a picture of the future that built a lot of popular support, that's kind of what these do too. And in this video, what's happening right now, this is supposed to be like a time lapse. I think of it as like Wonder Woman, like spinning around, when she like transforms into Wonder Woman. Does like modern Wonder Woman even do that anymore? I'm not sure. But right at the end there, you saw Mars go from being the red planet to be like covered in blue and green, right? And that's like that vision of terraforming, of taking Mars's environment and just transforming it. Now, private space companies have like a very wide range of motivations, but fundamental to all of their motivations, whether they want to go to the moon, whether they want to build missions for NASA, whether they want to put people in space, whether they're, selling space tourism, all of them want to turn a profit in some way. And so in some sense, these like very lofty things that we see in their marketing videos are about putting forward an idea of the future that they have like a significant place in. And in many cases, the motivations that those companies have for going to space, or whether it's going to Mars, whether it's going to the moon, et cetera, are not really in line with the motivations that might cause NASA to send something to space. Making a profit, maybe mining sounds great to you, because mining is something that turns a lot of profit for people here on Earth. In fact, Elon Musk's family wealth is from mining. And so, when we look at mining as something that could be potentially disruptive on Mars, for example, most of the mining is talked about for asteroids and the moon. But when we look at those activities, those could be counter to some of the things that are in the Outer Space Treaty about planetary protection. They could be counter to some of the scientific goals that we have. And they could be disruptive to the cultural significance of some of these places. So, what happens if there's a lot of infrastructure on the moon for mining? Like, what if it's visible from Earth? Does that change like how people relate to this thing that has been visible in the sky for literally all of human lifetimes? So, a lot of times the ethical questions that are significant to one group of people, say scientists, for example, might be a totally different set of ethical questions, or might be, actually an impediment to what private companies might want to do in space.
Wow, that's a lot to think about. And Brian Garrison brought up Starlink, which is a great example of, these private companies sending stuff into space that is actually blocking and impeding our view and our relationship with the night sky. I don't know if you want to talk about that, Lucianne or Aaron. Your thoughts on Starlink?
I'm sure Aaron has something to say about Starlink too, because almost every astronomer does. Yeah, so Starlink, actually, I gave a talk about this that is up. If you look for my name and Starlink and Vimeo, I gave a conference talk. It's only like 12 minutes long if you want to see it. And it's sort of intended for like a general audience that talks about Starlink as something that uses this concept of the greater good. So just briefly, Starlink is a satellite constellation. It's meant to provide internet across places of the globe that maybe don't have access to high-speed internet. And it is significant because it is the planned amount of satellites that are launched are in like the tens of thousands, like eventually like 40,000 satellites, which is significantly more things than have ever been in space before. And so astronomers are worried that it will contaminate, our ability to do astronomy. Some of those things are visible with the night sky, like with your naked eyes. So they might actually change people's relationship to space. People are worried about their environmental impacts because light pollution like that impacts wildlife sometimes. And people are worried about their cultural significance, their impact on just people who might relate to the night sky in any number of ways that might be disruptive. But I think what's interesting about Starlink is that they use this greater good argument that, astronomers who complain about Starlink are often like dismissed as being like, oh, like you don't want people who are in rural areas to have like accessible Wi-Fi, which is like totally not the case at all. Yeah. I would like you to have Wi-Fi. So, the thing is that Starlink, from all of the very minuscule information that's been released, is actually not cost competitive for most of the places on the planet that will be in need of its services. And in many cases, in I think Nigeria is an example of this. Local organizations have actually set up their own networks, or some of those places are actually served well by 5G networks. So, in many cases, Starlink is using this like, oh, we're doing this like greater good thing, and so you shouldn't be complaining about it, astronomers and people who like dark night skies. But in fact, like, there's no evidence that they're actually going to serve anyone who might be, what we think of as in need. And so, whether you're asking whether somebody can like stream Netflix in HD versus like access, basic human services is like a pretty different ethical question, right?
Yeah.
So yeah, that's kind of what I think about. Aaron,
Amazing.
how about you?
Yeah.
Well, I just noticed that Mark has an image taken by Cliff Johnson, and I just learned about this right now. This is Cliff Johnson, who's actually a member of the Adler Planetarium, working with Zooniverse and also at Northwestern with me. This is an image that was taken on November 18th using the dark energy camera on the Blanco telescope in Chile. And you can see Starlink satellites going right through the image, right? So obviously Cliff is not interested in observing the Starlink satellites. He wanted to see the stars behind it and measure it, but you can imagine how difficult this must be, because even I can just see with my eye that there's some satellite trails that are going, and those are the lines, by the way, that are across the image, that are going right through stars. And how can you measure the star's brightness when you have a satellite going through it? And this is the type of problem that, might impede all types of astronomical research from the ground. And that's a concern for all of us astronomers. And it should be a concern for everyone who's interested in astronomy as well.
Yeah, my husband saw the Starlink while we were in Hawaii early in the morning. We were just on the beach stargazing, and I got up to go get us breakfast, so I missed it. But he was like, "What is this?" Because we didn't know. We'd never heard of it before. It was really scary. Okay, so we're talking about all these different things. Is it, with all of these different concerns that we have, is it worth it to send humans to space? Aaron, why send humans to space? Is it necessary?
So, let me preface this by saying I haven't thought about this quite as deeply as Lucienne and some other people. But I do have some ideas of why it might be a good idea to potentially send some people to Mars. And I'm not going to go as far as, saying that we should terraform or mine the planet's surface. But, a few well-trained people could perform some very complex experiments that we can't do with rovers, with robots. And the people could do it more quickly, and they can make real-time decisions. And the decision making is something that people are building into the rovers, computers. But if you need to communicate between Mars and Earth, it could be anywhere between 3 and 22 minutes one way. So that can really slow things down. If you have a person on there running the experiment, you can do it more quickly. You can handle it and do more complex things. One other argument that I'll put out there that people have made, and I do somewhat agree with this, is that having people on the surface of Mars could be very inspirational for a future generation of space enthusiasts, people who want to work in technology, people who want to work in science and astronomy. And we need to get people interested in this. We need to continue people's interest in science. And maybe this is one way that we could do that. Maybe this would also increase kind of our, Earth morale or something, kind of bring people together in some way to see that we are all humans and we have someone out there. What do you think about that, Luciana Meredith?
Yeah, I definitely think that there are examples. So it's not like an either or. It's not like a don't touch Mars or like horribly exploit Mars, right? Like I personally am optimistic, and I think that there are ways in which we could potentially ethically explore Mars, even with human presence. I think that there are examples from exploration of the deep ocean and sensitive environments here on Earth where, we don't just send humans or just send robots. A lot of times when something like, you send like a robotic probe to the bottom of the ocean, for example, you might have scientists who are not in the sensitive environment, but are nearby and can do things like send commands more quickly, make real-time decisions, do repairs on the robotic probe. But you have something that is much less of a like walking biological microbial colony than a human being going to the place that you're actually trying to learn about. So I definitely think that there are ways that this could be done. As far as the inspiration piece, I really think it kind of depends. You know, some people find space exploration super inspiring. Some people don't. And some people feel conflicted about it too, right? I was thinking about in the 60s of the Apollo program, right? The 60s were a time of huge upheaval in the same way that we're seeing this upheaval for racial justice now. That was a very significant factor in the 60s as well during the civil rights movement. And, you know, one of the events that I think is so interesting is that Ralph Abernathy led a march on one of the Apollo launches and actually ended up in a dialogue with the NASA administrator at the time about the fact that we were sending people to the moon at the same time where people didn't have their basic human needs and their human rights. They didn't have their needs met and they didn't have their human rights being observed. And, you know, in many ways, some of those problems are still with us. One of the things that I think is really encouraging is that, you know, in the scientific community and people who work on things like planetary protection, one of the focuses that's really come to the fore is trying to, you know, separate ourselves from this history of colonialism that is often baked into how we talk about space. So things like manifest destiny, that like all humans, you know, go to space and want to go to space, you know, that like planets are ours to do with whatever we please. Like these are all examples of like colonial thinking. And a lot of work that's been happening most recently amongst planetary scientists and astronomers has been ways to think about space exploration that is not only ethical and considers, you know, the rights of other environments, but is also anti-colonial. Because a lot of times when, you know, people, for example, who are of indigenous origin in the Americas, just as like one small place on the earth, you know, indigenous people hear things like manifest destiny, and that's associated with a long history of harm, right? So that's not inspiring for them. Mm-hmm. And part of the reason that that's gone on for so long is that, you know, science in many ways is not very diverse. Like a lot of careers have not been accessible to people who are still in the same fight for, you know, racial justice, gender justice that they have been for a long time. So, you know, I think it could be potentially inspiring, but something that I think I am currently inspired by is the fact that scientists who are working on these missions are actively working on thinking about the ethics and like anti-colonial measures as well.
Yeah, you are so thoughtful, Lucienne. And I hope that folks who are watching this are learning something from this, because, you know, these conversations don't happen all the time, especially surrounding space. Becky has a really fun comment. We need a prime directive. And actually, Becky, that's kind of where I fall in this, you know, argument, is that I too am hopeful, but I always, you know, when I think of planetary exploration, I think of Star Trek because I'm a huge Star Trek nerd. And I think of this like storyline that comes through Star Trek, which is like they discover warp drive and then aliens come to them and say, hey, good job, you discovered warp drive. You can be in on all our secrets, which is, you know, like that kind of seems like a best possible scenario where we can have a conversation with these other aliens and, you know, we have all our ducks in a row and we're not just rushing into something to try and like prove ourselves as the human race and you know, so it's super thoughtful, and a lot of our problems on Earth have been solved before we even think about going elsewhere. That's my opinion. I'm a Star Trek nerd. So, all right. So hopefully everyone who's watched this has learned something. I like what you just said, Lucienne, too, about changing our language. Like, if nothing else, we can change the way that we talk about space and space exploration and making these decisions. But how are other ways that we as regular citizens and Star Trek nerds can be involved in these decisions? Is this something that we can vote on? Can we get a little voter sticker? You know, how can we have a voice in this?
Yeah, I mean, that's a great question because a lot of these things are not stuff that like comes up on a ballot, right? But I will say that something that always makes me optimistic is that the future is the future because it hasn't happened yet. And that means that the future is also unwritten. And anytime that we see like ideas about the future, and that's really like what science fiction images, whether they come via something like Star Trek or whether they come via something like a marketing video from SpaceX, these are all visions of what the future could be. And, we all share in whatever the future is going to be. So, I think even just asking a lot of questions about those things and those images and like who those futures include, who they don't include, who like certain narratives about space appeal to versus who they don't appeal to or who they actively harm. I think that those are all questions that we, can have answer, we can ask and have the right to ask. And so I think like having those conversations amongst ourselves, and also like talking to our representatives about science too, is never a bad thing. Almost nobody calls Congress about science. It's really sad. So, if you have opinions about this stuff, you have every right to express them and to start crafting also like what you think the future should be. And I'll just add that like a big part of that is also understanding histories of Earth. I think I didn't know a lot about colonialism when I was growing up. I knew sort of like the things that you learn in US schools. And a lot of that doesn't include a lot of people's perspectives. And I've been really like, I think my experience as a person has been deepened by understanding histories that aren't necessarily like histories of like me, a descendant of European immigrants, right? And so one of the things, for example, like I learned that the Prime Directive was written into Star Trek because it came out of sentiment around the Vietnam War at the time. So there's these super like strong ties between Earth history and current events and the science fiction futures that we see. And so like, I think looking at those and really like picking them apart and thinking about like who is in those futures is super important. It's something anyone can do.
Oh, I love this. Okay, we are out of time, everybody. Thank you so much for joining us today for Adler Astronomy Live. This was one of my favorite ones. Can I say that? Yeah. We hope that you enjoyed your experience. Once again, we would love it if you would consider donating to the Adler to help us keep programs like this running. Sarah is going to be sharing the link for donating. If we didn't get to your question today, please email askadler@adlerplanetarium.org. or tag us on social media using #AskAdler. And one of our experts will get back to you as soon as they can. We really want to be able to answer your questions. We're also going to be linking a survey so that you can give feedback on this program in particular. What would you like to see more of? What are you loving? Also, I would just like to say, please subscribe to the Adler's YouTube channel and turn on that bell. And I also just really quick want to plug that Lucy Ann and I have a really fun program that's going to be coming to the Adler's YouTube next week. And this is where you're going to get to see Lucy Ann's diorama that they built and also hear a song that Lucy Ann wrote. So if you already are just so impressed with Lucy Ann's vast knowledge, just wait till you see our program. It's called Wow Signal, and it's happening next week on Devil's Night, which I learned is actually just a pure Michigan thing, but that's the night before Halloween, October 30th. So subscribe to the Adler's YouTube channel and keep an eye out. Lucy Ann, thank you so much for joining and for sharing your expertise. This has been awesome.
Oh, thank you, Meredith. It's always a pleasure. And also, if you tune into the Wow Signal, you get to hear Meredith singing with her beautiful voice and doing all kinds of other silly things that I won't spoil for you. But yeah, tune in.
Yay! And Aaron, thank you so much for once again, always joining us with your expertise as well.
Thanks. And I'm really looking forward to this Wow Signal. It's a surprise to me too. I haven't seen it yet, so I'm looking forward to it.
And thank you to Mr. Mistopheles, Mark Subrau behind the scenes. He also helped with some Wow Signal stuff, so keep an eye out. All right, thanks everybody. We'll see you actually in a month. We aren't gonna have a program in 2 weeks. That's voting week, so make sure to get out and vote. Just wanted to say that one last time. All right, we'll see you in a month then. Goodbye. Bye.